This is a total change of pace from your previous talks this morning. Many of you know I'm a geologist by background, although I did do physics at Caltech once upon a time. A physicist likes the numbers and equations. A geologist likes to wave his arms. So you have to take what I have to say with we would say a grain of salt. But it's the only way you're going to make progress, in my opinion, is to look at what the profit potential of large systems might be. And so I want to look at the economics of a HIF, SPRFD system, that is the one that Bob and I have been talking about all week, in particular in a desert region where I have water as a byproduct. So this is where I want to talk about. We all know that as a society, we need baseload energy. It's fine and dandy to be very green and say I'm going to get all my energy from the sun and the wind. But frankly, the sun and the wind do not give you the energy you want. You want the energy to turn on at the switch, and you want it day and night, and you want it in large quantity. You have to have energy for electricity, of course, for fuels, for metal processing, and more importantly, in many parts of the world, water. I believe as a result of taking a look at the potential for a large-sized system, the market is there. It's compatible with existing infrastructure if you do it right. There is substantial potential for profit. And I'm going to give you a comparison with the current way we get energy versus what we would have if we had fusion online. And I'm going to do some applications to Iran because my two co-authors are Iranian. Energy is the lifeblood of all modern society. Without energy, you don't make it. The demand is growing at 2 to 4% per year. If you look at the gross national product of all countries per capita versus the energy consumption per capita, on a log plot, it's a straight line, of course. And what that says is that if you don't have energy, you become an impoverished society. If you do have energy, you become an affluent society. And that's exactly what the line on that plot says. I think you have to have it for a different reason. As a geologist, I'm concerned about the atmospheric impact our society is having. Certainly during my flying lifetime, which is longer than any of yours, because I'm the oldest person in the room. There is a very distinct change in our atmosphere. You see it every time you get on an airplane. You can't avoid it. People in Beijing know about it, etc. We have to reduce our atmospheric impacts. The need is for electricity, yes, but the need is also for a synthetic carbon liquid fuel. Why? I have to be able to use the CO2 that I'm discharging in the process of getting energy from fossil fuels, and I have to use that as the base carbon source for our future energy system. And I'm talking beyond my lifetime, unfortunately. But carbon neutral fuel is critical to any large fusion system. And the reason is you can't handle all the electricity a fusion system can produce. You have to make it, you have to produce some of the energy as a storable commodity. We've talked about what the system we're talking about, and I think the issue on this side that I want to, two issues. It's flexible in terms of its configuration. its thermal output is very large, and that thermal output has to be used in some way that society can accept it, and that is a liquid fuel, not electricity. Fusion produces heat, not electricity, and you have to remember that. I go at it from the point of view that fusion takes a very large amount of energy for its driver. It always will. Society needs a solution that brings back cheap oil, or the equivalent thereof. We grew up, whether you know it or not, my first job was drilling oil wells. We grew up at a time when oil cost $3 a barrel. My highest standard of living was shortly out of graduate school. Since then it's gone down. Why? The price of oil has gone up. We have to have an energy that has a large energy return for energy invested. For fusion, you can have that return. It can be as large as 50 to 100 times as much energy out as in. The economics get better with large systems. And the infrastructure is not ready to accept the large system, but if you make fuel with at least a portion of the energy you generate, it is very, very economical. I'll show you that in a minute. Here is what energy looks like. The industry standard 1 gigawatt unit, if you were made do it by fusion, would cost you 60 cents a kilowatt hour. That's too high for anything. If you look at it as a larger system, you can get it down immediately to less than 20 cents, and by the time you make a fully developed system of the sort that Bob Burke and I have been talking about this week, you can get down to maybe 3 cents a kilowatt hour, maybe 2.5 even. Here's an example of an economic model. Let's see if I can make this pointer work. You produce heat. That's your primary product. Heat is used to make electricity, but I do it via a distribution system that goes to electricity, but some of the heat bypasses and has to go to hydrogen synthesis. Hydrogen synthesis is much more cost effective if it's done at high temperature. So you balance heat to two different products, and you have a waste product over here that goes to water, desalination of seawater or other non-potable water sources. And there's a little number up here in the top corner. There's $19 billion a year that goes in your pocket for an $80 billion system, most of which is borrowed capital. You get all your capital back in less than a year. You have to think that the economics is there to drive this subject to completion immediately, but you've got to have focus on doing that. I just show you some numbers. You can calculate these numbers just like I can. But there is the potential that a large system could yield $38 billion a year even. Hydrogen is not just for fuel. Hydrogen is our basis of our food production system. It is fertilizer. You have to remember that. It's a very big market already. It's mostly produced from natural gas by stripping off the carbon, or stripping off the hydrogen if you wish, leaving the carbon behind. Water, well, a few countries south of you, Saudi Arabia, they produce huge amounts of water by burning oil and gas because they have to have water to survive. You also have to have water to survive no matter what country you're in, and it is becoming more and more critical every day. The capital cost considerations I used in my analysis were these. They are large numbers. There's the $80 billion I think it costs to build a full-up system. Its operating cost is like $7 billion a year. The profit, as I told you earlier, is $19 billion a year after you've paid all the expenses. I come back to water again. Most of you take water for granted. It rains, you get water from the sky. Where'd that water come from? It was evaporated from the ocean. Unfortunately, there are parts of the world where there isn't enough water to go around. And I'll demonstrate that in my last few slides from a place I know very well. Water is relatively cheap. A multi-effect distillation unit can make water. The capital cost is about $1,000 per cubic meter per day, and the equipment is fully amortized at 50 cents a cubic meter. Sorry, I'm talking in US numbers. They're the only ones I know that I think we all can convert to. A large system in Saudi Arabia currently produces 2.7 gigawatts of electricity from a gas-fired turbine. It produces 80,000 cubic meters of water per day. If I just use those numbers and scale it to fusion, I can get a number of up to 20 million cubic meters a day at a reasonable capital cost. And I use this in my analysis with Iran because that is a full 20% of their current consumption. And Iran has run out of water. That's why I put this talk together for a different purpose. And here are the reasons why it's important for Iran. They need the electricity for their growing population. They need energy without a carbon output. They need water for the popular industry and agriculture. How much water? Well, one system produces 15%, maybe as much as 20% of their current consumption. And it creates highly technical jobs. Now that's the basis of my real talk, but let me just give you an example of why water is so critical to us. These are tree rings. You notice that they're very close together out here, far apart in here. That's partly because young trees grow a little faster than old trees. But there's also a signature in there that you have to recognize, and it's been well studied throughout the world. Whoops. Here's one of the largest reservoirs in Northern California. It's empty. Here's the concern that, whoops, try again. Here's the concern that people have. The tree ring record says this, that it was dry for 200-year periods, very dry. And guess what? California has been developed during this 500-year period of wet weather. And suddenly, California found itself without water. This is one of their largest reservoirs. It's empty. It's partially full right now. We had a good rain this past winter, but it's going down in a hurry again. But what happens if our society really does have a 200-year drought? It happened in the past very clearly. This is the tree ring record that says that there are very dry periods, there are very wet periods. California has chosen to move water from the northern part of the state up here where there is a decent amount of water and they pipe it all the way down to here. Actually, it goes all the way to San Diego. Even after all that planning, and they did a pretty good job for a while, but they missed. There wasn't any water in the system. The reservoir system wasn't large enough. And of course, the system is long. It's close to 1,000 kilometers long. From the source areas in the northern part of the state to the consumption areas in the southern part of the state. And I point out they had to go over the mountain range to get there. But the people of Los Angeles are very happy with that water. It's what makes it survival. I think, and the reason I brought this in, is if you live in a desert climate, you're willing to pay this kind of price. The interesting thing is, that price is the cost of a large fusion system. If this were built today, it would be $20 billion for just the water collection and distribution system. You can do that anywhere you want in a coastal country, even if you have to lift the water 2,000 meters to get it to your people, to get it to where people live. So I encourage you to think outside the box a bit. Look at the objective. The objective of HIF 40 years ago was to put power online. And I think your focus has to be to put power online. So enough preaching, let's go have some coffee. I'll be glad to discuss this with any of you that wish.
Thank you very much.
Question, please. Okay.
Thank you, Charles. Since we talked a lot, I think I know what you mean, but maybe you can rephrase it. You mentioned being careful with carbon in the atmosphere. I think one should point out that it is more or less the dust and not the CO2 that worries you, if I understood you correct.
That is very correct. As a geologist, I'm not the least bit worried about the CO2 in the air. It's a nuisance. Plants take it out again. Geologically, it's been much higher than this. The Earth is still here. It's not a catastrophe really to CO2. The catastrophe is the breathability of the air, and that's the particulates in it. That's why that's the sulfur really. It is the fly ash from coals. It is the ozone that's being produced by your cars. That is what's damaging to your health and to the health of many ecosystems on the planet. It's not the CO2.
Another question? Comment?
So I have a question. How to make water in your system?
It's a distillation process. The question was, how can I make water from heat? I have to have water. I can't make water, but I can take saline water, ocean water, and make fresh water from it. And it's not what I plan to talk about, but it's a low pressure distillation where you use the heat over and over again to get more vapor. And it's a flash steam process, but it's at low temperature. So I can explain it to you in detail if you want. But it's not my technique. The company, if you want to read about it, write down SIDEM. Look it up on the web. There's beautiful illustrations and big plants that have been built. And it's also done in Korea, by the way, but I don't remember the company's name.
Okay, good idea. But what is? I want to know what is the Iran government involved in this project and how, when?
Well, I've had discussions up to assistance in the president's office about this. As yet, they've not agreed to put up money for it, but they have asked us to put a proposal together. We're doing that now.
Other questions? No. Time for...
Their reason is the economic issue of water. The rest of it, they couldn't care less.
Thank you again for very good talk.